Hi, so this video is going to talk about solving for three-dimensional word problems in grade 11 trigonometry. In this particular problem, we're using trigonometry to solve for an inaccessible distance, which is, in this case, the height of a cliff. So to find the height of a cliff that is inaccessible, a surveyor measures a baseline AC of 400 meters. So in this case, the baseline AC is representing a side of a triangle. In the horizontal plane, ABC, angle A is 27 degrees, angle C is 35 degrees, and in the vertical plane, so let's keep in mind that we're dealing with the horizontal plane and we're dealing with the vertical plane. So that is one of the indications that this is indeed a three-dimensional word problem. We're told that angle BCT is 18 degrees. Determine the cliff height to the nearest meters. So I'm also given the answer in this particular question, which is 67 meters. So if I'm drawing this, I know that I'm going to have a triangle that is in the horizontal plane, and then there's this vertical plane as well. It's going to look something like that. So if I have a cliff that's over here, and let's say this is the ground, and I'm trying to figure out what the height of this cliff is, well, we're going to pretend that this is 90 degrees here. It's standing up vertically, and I'm told, so in the horizontal plane, that this is called ABC. So angle A is 27 degrees. Angle B over here is, I don't know what angle B is yet, but I can figure it out because I'm told angle C is 35 degrees. So if I want to figure out what angle B is, well, all I have to do is do 180 degrees minus 27 minus 35. And when I type that into my calculator, because I don't really feel like calculating it in my head yet, I figure out that angle B is 118 degrees. So that's right over here. So now I know my horizontal plane triangle. I'm also told that in the vertical plane, BTC, right? So I'm told that this is the top of my triangle over here. B is over here and C is over here. I'm told that angle BCT, so if I'm going from B to C to T, that means C is in the middle. I'm told this angle is 18 degrees in the vertical plane. Okay, so now I know the vertical plane of that triangle. So basically this vertical triangle, I'm just going to redraw it over here in purple. So this is the vertical plane triangle right here. And I know that this is 18 degrees. I'm trying to figure out what the height of this triangle is. And I need at least one other side in order to find the height of that triangle. And I don't have any way of like getting the hypotenuse because it's not really connected to anything, but I do have a way of finding this BC side over here. I could find the side little t. So if I want to find side little t, it is connected to this horizontal plane triangle over here, and I have all of the angles for this. And I also know from the first part of the question that AC, side AC right over here, is 400 meters. So I know that its opposite angle is 118 degrees. So since its opposite side is 400 meters, that means I have an opposite side angle pair. I can use sine law. And I can use sine law to figure out this side T right over here. So let's go ahead and do that. So I'm going to be looking for T, and I know its opposite side in this triangle ABC is sine of 27. And I have 400 meters in that triangle, and its opposite angle is 118 degrees. So t over the sine of 27, my 27 kind of looks like a 4. There. T over the sine of 27 is equal to 400 over the sine of 118. So when I'm solving for t, that means t is going to equal 400 sine of 27 divided by sine of 118. So 400 times the sine of 27, dividing it by sine of 118, I'm left with t equals 205.6704, etc. meters. And I do want to keep at least 4 decimal places here because I'm not done solving my question. I now know what t is, so I can use t and in my vertical triangle and use it to solve for h. So I have h and t, that's the opposite and the adjacent of my angle 18 degrees here. So I'm going to use the trig ratio that has the opposite and the adjacent in it, and that is tan. So the tan of 18 degrees is equal to my opposite, which is h, over my adjacent, which I just solved for t, which is 205.6704. So when I'm solving for the opposite, which is the height of the cliff, I'm going to solve 205.6704 times the tan of 18. And I plug all of that into my calculator. I'm actually just going to use my answer button because t was the last thing I solved for. So I'm going to say answer times tan of 18 is equal to the height of my cliff, which is 66.8264. 0.826. It's actually like 36952, but I'm just, rounding it. Since I'm going to also round this to 1 decimal place, actually, my answer is rounded to no decimal places. It's rounded to the nearest meter. So I'm just going to do the same thing. 66.8 rounded to the nearest meter is 67 meters. And that is how you solve 3D word problems that are looking for a height, like in this question. So you're going to have a right angle triangle in the vertical plane, and you're going to have not a right angle triangle, but another triangle in the horizontal plane, and we need to essentially solve for the side that's connected to the right angle triangle. So in this case, we were looking for side T, which is also the same as side little a. So in this case, side little a, which was opposite of angle big A, is equal to side little t. So since that side was equal to each other, that's the one we were solving for. I use it in my vertical right angle triangle and solve for the height of the triangle.